All right, welcome back everyone. In this video, I'm going to be discussing the two-dimensional kinematic equations and how they can apply to both the y and the x completely separately. All right, so if you think back to chapter 2, right? I know this is chapter 4, but think back to chapter 2. Specifically table 2.1. That listed 5 kinematic equations to use in problems concerning constant acceleration. Chapter 2 was only one dimension at a time. So either in the y direction with gravity or in the x direction with an acceleration via some other means. Now in chapter 4, an object is being launched through the air and is traversing the x and the y directions simultaneously. And so, because of that, we're only dealing with the force of gravity, creating only one type of acceleration, right? Little g. And that only points downwards, right? In the negative y direction. There's no acceleration horizontally. So let's first start off by copying down those equations from chapter 2. Okay, so let's say, first off, let's say number 1. The first equation was the final speed equals the initial speed plus acceleration times time, right? This is just a simple rearrangement of the definition of acceleration, okay? Equation 2 was for the final position, right? X as a function of time. So the initial position plus the initial speed times time plus 1/2 acceleration times time squared, right? I'm not canceling any terms out yet. The third equation, that should have been the final speed squared equals the initial speed squared plus 2a times the change in position. The fourth one is the change in position, x minus x naught, equals 1/2 times the sum of the initial and final speeds times time, right? And then the fifth one was the difference in position equals the final speed, specifically v times t, minus 1/2 at squared. Okay? And the table also lists, if you're missing specific quantities, which equation would be best to use, right? For example, equation 3 here would be best to use if you didn't have time, okay? If you go back, if you're curious where these equations come from, right? They don't just appear out of thin air or from a textbook, right? They come from somewhere. And they come from, well, this one came from the definition of acceleration. This one comes from the fact that you can write the definition of speed, right? The average speed, 2 different ways. And solving each of these for time, and solve this one for time, set them equal to, you get this equation, right? That's a fun exercise. And if you solve them both for acceleration, you get this equation. And if you solve them both for the initial speed, v naught and v naught, set them equal to each other, you get this equation, okay? If you're curious how that happens, right, it's fairly straightforward algebra. I encourage you to go ahead and do it. It shouldn't take you too long, right? But you can get all 5 of these kinematic equations straightforwardly, okay? Now, that's from table 2.1. Notice I've always written it in x. Let's write it in y. So let's do horizontal, right? And now we can do the vertical. All right, same exact equations. So before I do that though, I should specify that each term, except for time, in these equations has to be in one of those 2 directions. So for every one that's not specified, I'm specifying x, 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 right? Almost there. Okay. Every term now is specified to be an x, except for time. That's not spatial. The vertical direction, guess what I'll do? Well, Vy equals V naught y plus a y times t. Right? Now, instead of x, it's in y. Why? I don't know. That was a bad joke. Okay. V naught y times t plus 1/2 a y t squared. This might take you a couple minutes. Feel free to just fast forward. Well, not a couple minutes, but it'll take me a little bit. Y minus y naught equals that. 1/2 as a constant. V naught y plus Vy times t. Excuse me. Y minus y naught equals Vy times t minus, notice I'm keeping the signs here, okay? And yes, that minus sign in this equation works out to be a minus sign. It has to be there. All right. So now I have them both, the exact same equations, in either the horizontal or the vertical. Now, let's see what cancels out. All right? If we're talking about chapter 2 or chapter 4 with two-dimensional kinematics, we're only talking about the gravitational force in the y direction. So there's only acceleration in the y direction. So that means that ax is 0, right? There is no acceleration horizontally. So that term goes away. This whole term goes away. And this term goes away. And so we can write that. I'll just use my, whoa, that was a big eraser. I'll write that as, using my fancy eraser here, as just these. So the x equations simplify a little bit. And it should make sense, right? The final speed equals the initial speed horizontally because there's no acceleration. Same thing here. So equation 3 reduces to equation 1. You'll notice equation 5 is simply the definition of speed. And this equation here is the definition of average speed if you work it out. Okay? So the horizontal equations hopefully work out to be fairly intuitive. For the vertical direction, we can change a couple things. Now, AY is equal to negative G. Okay, negative G. And I say it's negative G because in your problems, it'll be easiest for you if you always assume that up is positive. Okay, it'll just help you out tremendously. Up is positive y and right is positive x. Okay, and so in that case, we can rearrange these equations a little bit. Let's put in a minus g there. And this becomes a minus 1/2 gt squared. This becomes minus 2g delta y. And in equation 5, it becomes now plus 1/2 gt squared. Okay, so these are how the vertical equations change. Notice I haven't canceled anything out. All right, so moving forward, these are the, well, 10 or a little bit less than 10 because a couple are on the same. These are the equations that you should use for two-dimensional kinematics. Okay, so I hope you have noted this, right? Write these down, put it on your exam cheat sheets, right? And hopefully you'll use these equations enough to memorize them, right? To know them by heart, all right? So with that, we're all set on this video. Thanks for watching.